Hello world. Okay. I'm going to start by pulling up the problems from the form. So let's see what people submitted. Okay. Now again, I haven't seen any of these problems before. So this is the first time I've seen them. Okay. Here we go. Okay. Okay. I'm just going to start with the very first problem that's given. Okay. Oh, actually, I want to see who submitted these, so... okay, this is submitted by GG, it's me. I don't know who that is, but, okay, so we want to evaluate, I'm going to copy and paste this, the indefinite integral, or actually the definite integral, from 0 to pi over 2 of this big mess. Okay. 0 to pi over 2 of this giant thing. Okay, so it's 0 to pi over 2 of 1 over a squared cosine squared x plus b squared sine squared x all squared. Okay. Okay, cosine squared plus sine squared is 1. So I could get everything in terms of sine squared or cosine squared. I could get everything in terms of cosine of 2x, and then that would be easier. So, okay, let's see. So I get, cosine squared is 1 plus cosine 2x, oops, not squared, cosine 2x over 2, and then sine squared is 1 minus cosine 2x over 2. Okay, and then, this is gonna get a bit messy. Oh, okay, well for one thing, cosine and sine are symmetric around pi over 2, so, that could come in handy. I'm not sure at this point. Okay, so a squared 1 over a squared plus b squared over 2 plus a squared minus b squared over 2 times cosine of 2x. Okay. Okay, I'm just going to call this, I'm going to write alpha plus beta cos 2x because that'll make it easier to write down every time. Okay, so now I can make a substitution. So I'm going to let x be u over 2. So then I get, just so that it's just regular cosine x. So I get 0 to pi of 1 over alpha plus beta cosine u squared times 1/2 du. Okay. Let's see. Okay, I know a trick that will work here, but I'm trying to think if there's a better way of doing it. Okay, I guess I'm just gonna go for it. 1 over alpha plus beta cosine u squared du. Oh, I could do differentiation under the integral sign. Maybe that's more complicated than necessary, but do I want to do that? Oh, I think I know what to do. Okay. I'm going to write it as a, well, not quite a geometric series, but, so let me erase this. Okay, so 1 over 1 plus x squared is 1 minus 2x plus 3x squared minus 4x cubed, and so on. Okay, so this integral will become, so I'll write I for the integral. So it's 1/2 integral from 0 to pi of, now beta over alpha has to be less than 1 in absolute value, otherwise I'm going to have a problem when I hit cosine equals plus or minus 1. So I'm going to expand this out. So this is within the radius of convergence. So it's 1 over alpha squared, and then times this power series with x equal to beta over alpha cosine u. So 1 minus 2 beta over alpha cos u squared. Oh boy, this is going to get messy. Plus 3 beta over alpha cos u cubed. Oh wait, no, sorry. That's just a power of 2, power of 1, and then a power of 2. Okay, well, here we go. So 1 over 2 alpha squared out front, 0 to pi over 2. Okay, now cosine u, or sorry, no, this is 0 to pi. So I've got 1 minus 2 beta over alpha cos u plus 3 beta over alpha squared cos squared u. Okay, so now cosine u, I want to evaluate the kth power of cosine. So, oh yes, hi, you can submit a problem. There should be a link in the description for this video where you can submit problems. Okay. Ugh. This probably isn't what I'm supposed to be doing. I mean, I know there's a formula for this, but okay, I'm just gonna cheat a little bit and use some complex numbers. Okay, so let me get rid of all this. Okay, so I'm going to use some complex analysis here. So I'm sure there's a clever way of doing this without complex analysis, but I don't see a way of doing it in a way that isn't super complicated. At least not at the moment. Okay, so cosine u I can think of as e to the I theta plus e to the minus I theta over 2. And, oh shoot, this doesn't go all the way to 2 pi though. Oh wait, no, it's symmetric. Okay, so I can write this as 1/4 times the integral over the whole interval from 0 to 2 pi. And now I'm going to let z be e to the I theta, so it's z plus z inverse over 2. And now I'm going to get a contour integral. Okay, so this integral is going to be 1/4 integral, and now it's over the unit circle. So it's going to be, here's my unit circle. 1 over 1 plus, alpha plus beta. Alpha plus beta z plus z inverse over 2 squared. And then I've got a du let's see. Oh, sorry, this should be u, not theta. Okay, so z is e to the iu. So dz is ie to the iu du. So du is dz over iz. Okay, so this whole thing times dz over iz. Okay, so I equals 1 over 4i times the integral of, oh, well, that 4 I can absorb into the bottom, actually. So maybe I'll just write it like this. So it's 1 over iz times 2 alpha plus beta z plus beta z inverse squared. Okay, now I need the residue of this thing. Oh, thank you, hi. Okay, I will get to that. If I have time, I'll get to yours. Otherwise, it might have to wait for a later video. Okay, so it's going to be, I have a z in the bottom, but I want a z squared to clear the denominators. So I'm going to get a z over I times z squared times this thing. So it's 2 alpha z plus beta z squared plus beta all squared. Okay, that's a big mess. And this is going to be 2 pi I times the sum of the residues. Of this big mess. Okay, what will that be? I just have to figure out where this denominator is 0. Well, that's a quadratic. And beta is smaller than alpha. So, okay. Let's see. When f, that will be 0. Let me figure out when this is 0. Okay. So beta z squared plus 2 alpha z plus beta is 0. So z equals minus 2 alpha plus or minus root 4 alpha squared minus 4 beta squared all over 2. So that's minus alpha plus or minus root alpha squared minus beta squared over 2. So if I pick a minus sign, or not over 2, there's no 2, that goes away. Okay, if I pick a minus sign, I'm going to have minus alpha minus something. Let's see. Yeah, okay, I guess I have to figure out. Okay, so then the residue is going to be, oof. Okay, maybe I'll set that problem aside. I'm sure I'm doing something wrong there. There's got to be an easier way to do all that. Okay, I'll come back to that. Oh, I was trying to solve an integral. Let me show you which one I was trying to solve. I was trying to integrate 1 over a squared cosine squared x plus b squared sine squared x, all squared. I think I've actually seen this before, but I don't remember how to solve it. I could do differentiation under the integral sign and start with just without the square in the denominator. It would be a lot easier. I'll come back to that. Okay, let's see the next submission. So sorry, GG, it's me. I'm gonna have to come back to that. Okay, this is from Number Theorist 93. Let's see. Okay, I have to solve, and this is an interesting equation. Okay, I can do number theory, so maybe I'll have better luck with this one. Okay, so I have to solve this equation. 4n to the 4th plus 7n squared plus 3n plus 6 equals m cubed. Okay. Okay, so I know that this is just going to have a finite number of solutions because, well, pretty much any Diophantine equation where the powers are 3 or larger is going to have only finitely many solutions. So, let's see, does the left side factor at all? Oh, it does. Okay. So I've got, if I plug in, wait, I think it does. If I plug in -1, oh shoot, no, it doesn't quite work. So I want the left side to be a cube. Well, okay, maybe I should start by trying to find some solutions. So if n is 0, I get 6, which is not a cube. If n is 1, I get 11 plus, no, that's not going to be a cube. Okay, -1, I get 4 plus 7, it's 11. Maybe I won't ever get a cube. If I could try taking mod 3 or 9, something like that. I mean, I noticed that there's a cube there's an n cube term missing. Maybe that'll be helpful. I don't think I can really complete the quartic here. Let's see. Wow, this seems tough. Unless there's a way to prove that there are no solutions with modular arithmetic. Okay, so first of all, if I take it mod 2, I get n squared plus n is m cubed, so m is even. So then the left side is a multiple of 8. So then, for example, 4 divides 7n squared plus 3n plus 6. Okay, so 7n squared plus 3n is 2 mod 4. So I could write that as minus n squared minus n plus 2. So n is 1 or 2 mod 4. Does that give me a contradiction? If it's... oh, well, squares are always 0, 1, or 4 mod 8. Okay, if n is even... maybe I should take it mod 8. I don't know. Okay, if n is even... okay, if n is 0 mod 8, I get 6 on the left, which is bad. If n is 1, I get 11, I get 20, which is also bad, I think. Yeah, because m is... okay. Okay, if n is 2 mod 8, I get 28 plus... oh, shoot. Okay, that could work, actually. Okay. Wow. These are tough. Okay. I might have to look at a hint in a few minutes. I guess I could alternatively try to fix m and see when I'll get integer solutions. So this left-hand side is a quartic that, I mean, if I get rid of the m cubed, it's going to be growing very quickly. So, I could try writing the left side as a difference of 2 squares. Wow, this is tricky. Okay, I'm gonna look at a hint and see what he said. Okay. Ah, I was close. Okay. So try mod 9. Okay, so let's see. Let's see what happens when I take it mod 9. Yeah, I mentioned that, but for some reason I didn't go through with it. Okay, so try mod 9. Okay, so mod 9. Oh, is there a faster way to do this than just... plugging all of them in? Gosh, I hope so. Okay. Oh wait, no, I don't need a 9. I just need an 8. Okay, so 0 I get 6. And the only cubes mod 9 are 0 and plus or minus 1. So if I plug in 1, I get 20, which is 2. If I plug in 2, oh gosh. Okay. 4 times 2 to the 4th is 64, so that's 1. Plus 7 times 28, that's a 1. Plus, that's 2 plus blah blah blah. No, that doesn't work. Okay, 2 plus a multiple of 3. Well, 2 plus 12, which is 14. Okay, that's 5. That doesn't work. If I plug in 3, I'm in trouble because the first 3 terms are divisible by 3. And the last one isn't. Oh, one second. Let me close the door. Okay. Then for 4, I get 4 times 4 to the 4th, which is, oh boy, something big, 1,024. 1,024, what is that mod 9? To the 10th. That's a 7 mod 9. Okay, 7 mod 9 plus 7 times 4 squared is 7 times 7, which is 49, which is a 4. Plus 12, which is a 3, plus a 6. So that's 11 plus 9, so that's a 2. Okay. Yeah, I think this'll work. Okay, and then for 5, well, I can write these as the negatives of the previous numbers. So negative 4, negative 3, negative 2, negative 1. Okay, so for negative 4, it's the same thing except this n is flipped. So when I plug in 4, I get 2, and when I plug in minus 4, I'm going to be subtracting 6 times 4, which is 24, which is the same as adding 3, so that's a 5. When I plug in negative 3, I'm going to get 6 again. When I plug in negative 2, I'm going to be subtracting 12, so that's negative 7, which is a 2. And then when I plug in minus 1, I'm going to get 2 minus 6, which is minus 4, which is 5. Okay, whew. Okay, so there are no solutions. Okay, so mod 9 ended up being the key. Yeah, it was kind of annoying, but it wasn't too bad, actually. So thank you, Number Theorist 93. Okay. Let's see. I'm probably just going to go for another half hour or so. I know I've only made it through a few problems, but I'm planning on having this be a pretty regular thing every week or two. Okay, well, since some people submitted problems recently, let me go to those so that I can try them live while you're here. Okay. This was submitted by Jacopo Rizzo. Okay, I have to compute the sum of the reciprocals of the Catalan numbers. Okay, this was 625. Oh, interesting. Yeah, I guess if you replace n by n plus 3, it's invariant. I didn't notice that, but interesting. Yeah, that's a good observation. Okay, so here's the problem. It's in latex form, so I'll write it in a nicer form. So Cn is the nth Catalan number. It's 1 over n plus 1 times 2n choose n. And I want to find the sum of the reciprocals of those. Okay, so that's going to be n plus 1 over 2n choose n. Okay, so I know that if you have 2n choose n in the denominator, there's a nice way of, you can get a nice power series out of that, but I don't know offhand what it is. So, I'm going to write this in terms of factorials. Okay, so it's n plus 1 factorial. Let me zoom out a bit. Oh, maybe that's too much. Okay, n plus 1 factorial over 2n factorial, and then I have n factorial, or no, where'd I get the n? Yeah, just n factorial, like that. So the n factorial, one of the n factorials from the denominator comes up, and it becomes n plus 1 factorial. Okay, now I'm going to turn this into an integral. I'm not totally sure that this is going to work, but there's something called a beta integral, which says that, well, it's usually written with alpha and beta, but okay, so if I take the integral from 0 to 1 of t to the alpha minus 1 times 1 minus t to the beta minus 1, that I can write that in terms of the gamma function. It ends up being gamma of alpha, gamma of beta over gamma of alpha plus beta. Or in terms, well, for integers, it becomes factorial. So it's alpha minus 1 factorial, beta minus 1 factorial over alpha plus beta minus 1 factorial. So for example, well, when alpha and beta are 1, I get 0 factorial squared over 1 factorial, which works. Or when beta is 1, I get alpha minus 1 factorial over alpha factorial, which is 1 over alpha. And that makes sense because I'm just integrating this thing. Okay, so I'm going to choose my alpha and beta so that it matches these terms in the series. So I let alpha be n plus 2, beta be n plus 1, and then the denominator is n 2n plus 2. Yeah, so I should be summing this integral t to the n plus 1, 1 minus t to the n, but then I divide by 2n plus 1, 2n plus 2. Okay, so the numerator integrates to n plus 1 factorial, n factorial over 2n plus 2 factorial. Oh, no, I need to multiply. Sorry. Um, 2n plus 1, 2n plus 2 times this whole mess. Okay, so now this is, I can write this as a power series, so it's the integral from 0 to 1. I'm changing the order of summation. Sum from n equals 0 to infinity of 2n plus 1, 2n plus 2, t to the n plus 1, 1 minus t to the n, dt. Okay, that's a little scary. Maybe it would be better. No, I guess I'll go ahead with this. Okay, so I'm going to pull out a t. And then I've got t times 1 minus t to the n. Okay. Now, this, if I replace t 1 minus t with a, with just an x, that power series should be pretty nice. I'm trying to think of what it would be. So, sum 2n plus 1, 2n plus 2, x to the n. So that's 4, the sum of 4n squared plus 6n plus 2, x to the n. Okay, so the sum of n squared, x to the n is, I don't quite remember offhand. Something with 1 over 1 minus x cubed. Shoot. Okay. Oh, well actually, the whole thing will be some polynomial some quadratic polynomial over 1 minus x cubed. So, one second, I have to plug in my laptop. Okay, I've learned today that I probably don't solve problems in the simplest possible way, but, okay, so what is 1 over 1 minus x cubed? It's 1 plus 3x plus okay. I know what 1 over 1 minus x squared is, so that's 1 plus 2x plus 3x squared. And then times, oh, I'm out of pages. Let me add a bunch more. Oops. Okay, now, I multiply that by 1 plus x plus blah, blah, blah. Okay, oh yeah, so it'll be 1 plus 3x plus 6x squared plus 10x cubed. It'll be n choose 2 for the coefficients. So, okay, so that's sum n plus 2. Wait, what is it? Over 2? Or n plus 1, n plus 2 over 2 x to the n. Okay, so what does that give me? Okay, so yeah, I don't think this isn't going to be good because now I'm going to have I'm going to be integrating something with a cube. It's going to be something with 1 over 1 minus t, 1 minus t, all cubed. Okay. Let me see if I could come up with a cleverer approach. Oh, one thing I could do is just forget about the n plus 1 and then differentiate, create a power series out of it. Oh, have I ever considered streaming on Twitch? I don't know of any people who do math on Twitch, but just stop wasting your time doing all this? Wow, okay. Okay, maybe I'll use a hint then. Oh, this does say, okay, this says exactly what I was trying, the beta integral. Wow, okay. I don't see how it's going to be simple to evaluate, but okay, well, I'm kind of scared of going through all the details, so let me go to a different problem. Okay. Next one. This is from Rohan Shivakumar. Oh. This is in the form of a Techer link on Art of Problem Solving. Oh, I don't think I can see it for some, wait. No, it doesn't work for some reason. I think you might have to make it public. Sorry about that, Rohan. Okay, so I'll go to the next one. Oh my gosh. Scary geometry. I'm gonna come back to that one. Sorry, Taco 12. Okay, this one, this is another problem from Taco 12. I think I can handle this one. Okay, so this is a number theory one. So we want a to divide b to the fourth plus 1, b to divides a to the fourth plus 1, and square root a. Oh, thank you for fixing it. Okay, square root, the floor of square root a is the floor of square root b. Okay. So a divides b to the fourth plus 1, b divides a to the fourth plus 1, and floor square root a equals floor square root b. Interesting. So that's saying that a and b are fairly close to each other. So let's say that this is equal to n. So then, let me get rid of that. Okay. So a is between n and n squared plus 2n. And same for b. Or sorry, that should be a b. Okay. Now, okay, let's say a is bigger than b. Yeah, you can definitely, it's okay if you say what your Twitch channel is. I haven't considered it, but maybe now I will. Streaming on Twitch, because I know that's more for streaming than YouTube is. And I think I'm gonna probably tend toward more streaming and less recording videos in advance. Yeah, so A and B are close together, which tells me that A and B can both be 1. If B is 2... Okay, well, I'm just going to list some solutions and see if I can find a pattern. So I've got 1, 1. A can be 2 and B can be 1. Or really, oh yeah, 1 and 3. Or 3 and 1. Because 4 of root 3 is still 1. But maybe those are all the solutions up to permutations. Because well, B divides... I mean, I could do something like A divides a to the fourth, b to the fourth, plus a to the fourth, or something. Would that be helpful? I don't know. Yeah, maybe I could stream on Twitch and then record on YouTube. That might get more viewers, I'm not sure. I could say A is n plus something, n plus r, b is n plus s, and r and s are between 0 and 2n. And then, or I could say b is a plus something. Let's see. I'm not used to doing problems this tricky live. I mean, I've done the Amy and AMC problems, but those are a little more predictable. think, hi, you're Taco12, right? You're the one who submitted this? Because I might need a hint soon. I could say that A divides the product. I could do, well, can they share? They can't share any common factors. Wait, what? In the square, not in? Huh? Oh. Yeah, so... Okay. Yeah, I was confused about what you were referring to. Okay, sorry. So... A and... Yeah, okay. Doi. Okay. I am A1101. Oh, or 1001, sorry. Okay. I mean, okay. AB divides A to the 4th plus 1. B to the 4th plus 1. So AB divides A to the 4th plus B to the 4th plus 1. I don't know if that's helpful at all. Wow. Oh. Taco12. Can you give me a hint? Or at least tell me if I'm doing something right? Oh my, it's the team selection test? Okay. Let's see. Okay. I don't feel so bad for having trouble with this one. Dang. Yeah, dang is right. I mean, I could try, yeah, I could say, like, B is A plus something. B is, or I guess A is the bigger number, so A equals B plus N. Then, B divides B plus N to the 4th plus 1, and, B plus N divides B to the 4th plus 1. So, B divides N to the 4th plus 1. And B plus N divides B plus N minus N to the 4th plus 1. Oh, so B and B plus N divide... Oh, wait. No. Sorry. B divides N to the 4th plus 1, and B plus N divides B to the 4th plus 1. I can give you... Well, okay, if you give me an AOPS link, as long as it isn't 2... Wait, 1, 3 doesn't work? Oh, 3... 3 doesn't divide... 2. Okay. Let's see. I think you gave me a hint. The common for... Okay. You start out in the same way. And I thought A and B are relatively prime. Yes. Okay, so we started out in the same way. Okay, I'm not going to read the whole solution. I'm going to try to patch it out. Oh, I think I see. Yeah. So A divides... A divides... A and B both divide A minus B to the 4th plus 1. So they're relatively prime, so AB divides A minus B to the 4th plus 1. Okay. And then A minus B is at most 2n. And AB is bigger than n squared, because we're assuming they aren't equal. So a minus b to the fourth plus 1 over ab is an integer, but it's at most 16, 2 to the fourth. I don't think it can be exactly equal to 16. Okay, I have to go in a few minutes, unfortunately, but let's see. So then I just try everything? What can I do? Well, fourth power, a minus b to the fourth, to the fourth plus 1 is less than 16ab. And usually if a minus b is decently large, the fourth power, that's going to be huge. Oh wait, let me see if your earlier problem link works now. Oh, I can't see it, but you can always resubmit it and construct ABC with AB 8, 12, 10. Okay. I will have to try that next time. Unfortunately, I have to go in just a few minutes. So maybe next time I'll have a... I think I'm pretty busy next Saturday, but maybe the Saturday after that is Christmas. Okay, at some point in the next few weeks, maybe on a weekday, since I'm going to be on break, I'll have a longer problem-solving session, maybe 2 hours. I think I'm going to set this problem aside. Oh, thank you, Love Udeshi. I'm going to come back to this next time. So maybe I'll have... let me look at my calendar. Yeah, maybe sometime next week or the week after, I'll come back to this and I'll work on some more of the problems. There's still a lot more to get through. I have 24 problems currently, and I've solved, let's see, 1.5, I guess you could say. So this is taking longer than I thought, but it'll give me more to discuss. So I apologize for not finishing that problem, but I will come back to that maybe Wednesday next week. I'll have another live stream, and I'll think about streaming on Twitch if enough people are interested. And if you have any more problems, I definitely appreciate them. I'll make these live streams longer so that I can cover more problems. So thanks for coming, and I'll see you on